Okay, so if we look at this one, we can see that we're given information about the hydroxide. We need to calculate the hydrogen ion concentration. And Kw divided by hydroxide is the hydrogen concentration, which is 1.3 times 10 to the negative 9th molar. This is smaller than the hydroxide concentration, so the solution is basic. So now, this sort of moves us forward to start introducing the concept of pH. Now, pH was supposed to be introduced into Chem 111, where you learn to calculate it as negative log of the hydrogen ion concentration. And we use the pH scale to determine acidity or basicity of a solution. When the pH is 7, and this is only at 25 degrees C. Okay, this is at 25 degrees C. If you're at 60 degrees C, the pH of water is not 7. It's like 6.98 because we're going to find out it's related to the Kw value. But this is only at 25 degrees. So acidic, we're less than 7, and basic, we're greater than 7. And we said in Chem 111, we find pH by determining the negative base 10 common logarithm of the proton concentration. Since the hydrogen ion concentration is 1.00 times 10 to the negative 7th molar, then the pH is equal to 7. At other temperatures, the pH is not 7 for pure water. As the pH increases, the hydrogen ion concentration decreases and you become more basic. As the pH decreases, the hydrogen concentration increases and you become more acidic. Now, we can also introduce the concept of pOH because the little p for us means a mathematical function, negative logarithm. So p anything is negative log of whatever. So pOH is the negative log of the hydroxide concentration. Now, we can look at some mathematics to determine the relationship between the pH and the pOH and pKw. So we start off with our relationship. We've already established from our equilibrium expression for the dissociation of water that hydrogen times hydroxide is equal to Kw at any temperature. So if I take the negative logarithm of this equation minus the log of the hydrogen concentration times the hydroxide concentration is equal to minus the log of Kw. Now, we said minus the log is our P function, what we're calling that. So when I look at this, I have the hydrogen times the hydroxide concentration multiplied together in these parentheses. And you remember from your introduction to logarithms that if you take a log of something that is two numbers multiplied together, you effectively take the log of each and add them. So, minus the log of the hydrogen concentration, hydrogen ion concentration, plus minus the log of the hydroxide concentration is equal to minus the log of Kw. So when we take these negative logs and turn them into our P functions, pH plus pOH is equal to pKw. Now, at 25 degrees Celsius, Kw is 1 times 10 to the negative 14th, so pKw is 14. So pH plus pOH is equal to 14 at 25 degrees C. Now, how many of you learned this in your biology classes or some other chemistry class? And did they tell you anything about temperature? No. They just pulled this out of the sky. pH plus pOH is 14. It's not. pH plus pOH is pKw. And pKw just happens to be 14 at 25 degrees. And I want to really make sure you understand that because at any other temperature, pH plus pOH equals pKw, and pKw is not equal to 14. It might be 13.8. Okay? So that's really important because in Chem 112 we do talk about other temperatures. Most of the time we're at 25, but there is a section where we talk about that relationship at other temperatures, and there's always something at other temperatures on the test. And it just makes me crazy when I see my students doing that other temperature problem and writing 14. Yes?
So would you, if we were using a different temperature, would you give us this little chart where it tells you
You'd either have that chart or it would say at 60 degrees KW is this, right? So you'd have that information. I don't expect you to memorize that. It's not inaccurate. It's designed at 25 degrees Celsius. It's very accurate. And if you change the temperature, then you change the numbers. Okay? So no, it's not inaccurate. It's just that there is an assumption that nobody talks about. How many of you have ever heard this, that 14 was tied to 25 degrees Celsius? Nobody, right? Because we don't talk about it until now in chemistry. And in biology, they never talk about it. And they're not at 25 degrees Celsius, right? Living systems aren't 25 degrees C, are they? What's a body temperature in Celsius? 37, yeah, so that's way higher. So when you think about that, what's the pH of blood? It's slightly basic, right? Yeah, so I'm wondering how basic it really is when you consider it's at 37 degrees. Okay, once you take it out and put it in the refrigerator, then maybe it's different, but when it's doing its job and it's at 37 degrees, if that's really the pH, I don't know, because it's hard to measure the pH when it's in. Yes, it'll keep it around the same range regardless, but the number that it keeps around is different based on temperature. Yes, it is buffered. And that if you screw that up, you get really screwed up, right? If you mess up, you do. It's a great